Hello everyone, this is the topic Introduction and the Application of Reinforcement Learning. Machine learning. Machine learning can be divided into the three types: supervised learning, unsupervised learning, reinforcement learning. Supervised learning features the learning mode of the making prediction after analyzing patterns in label information. The metadata is like a sentence answers. During the learning process, the computer makes corrections to achieve a more accurate prediction by comparing the errors. Unsupervised learning feature the training data doesn't need to be labeled manually. When the machine fetches the data, the process is to the classify according to the correction. Find out the potential rules and the routines, and from the concepts. Reinforcement learning feature. There is no need to give the machine any information. Let the machine learning direction from the interaction. The machine learns from the positive and the negative feedback of the environments, and gradually from the extension of the feedback stimulus, and makes more and more efficient action to achieve the goal. This trend, the goal of the process is to action maximum benefit.
We will introduce multiple decision process. It's among the state and the reward are at the time are only related to the state and the action at the precise moment, which is called NDP. The NDP diagram is constant decision, try and error, and explain the grading reward. Next, let's introduce the multiple strategy path. Is responsible of the property of the choose A in the state. We can define the pi strategy value function and the action value function. And the following is the variable formula. And where E pi is the expression value under use the strategy pi. If pi is between 0 and 1, then strategy. And if the pi is equal to 0 or 1, then dimensional strategy is the upper middle strategy. Besides, accumulation reward is important for this formula. Gamma is the discount factor, and if gamma is 0, it introduces the agent only constant the current reward. The purpose of the gamma approximation equal to 1. Agent will constant more long-term reward. This picture is show that GTA outperforms GDP when the gamma is equal to 0.8. It is the experimental implementation we design according to the paper. Session the action leave the grade with a minus 0.5 reward. The reward for leave the action from A and the B is the 10 and the 5 respectively. And the result of the action reward is the 0. In the right picture, it's the value each action for each state. Then, behavior introduce the expression grid. There are two situations. First is the grading chooses the curve-based action reward, but this behavior makes it possible to find separate upcoming behavior situation. And the other is the input to curve experience behavior experience very long-term benefit.
And now I will introduce what is Q-learning. Q-learning is used to calculate best action value function. In the middle left graph is talking about Q-learning's architecture. S means state, A means action. Put S and A into stack action pair. state action pair is an algorithm. Then we can get the Q value. Q value, the bigger the better. Bottom of this page, we can see a formula. This is the Q-learning update method. Max reward is target of Q-learning. Q-learning disadvantage is one pair of state action pairs correspond a reward. When data of system too huge, it will make Qtable too big to cause of dimensionality, and efficiency drops. To solve of this problem, we can change output to Q-value vector correspond every kind action. In this page, I will introduce what method of our project useful. We use deep Q-learning, we call this DQN. The difference of Q-learning, we use neural network in QSA. This method can complete the task with a high probability of state S when the environment remains unchanged. But when the environments change, the agent will make big mistake. Because this method is online training, which means that every time the algorithm executes a training loop. In other words, means when this program works every step, the parameter of the neural network will be backpropagated and updated once, resulting in futile learning. In this page, this is our architecture. First, put initial state in major Q network. It will predict a Q value array and select one of value to let red block produce next step. After put next step back to major Q network. Repeat and round. When state t+1 produce, we also put it into experience pool. Experience pool can save state action, reward, and state t+1. When experience pool save enough data, take out data from experience pool. That's its batch size. Put those data into target Q network. Predict a target value. Put target Q value in major Q network to do training.
Yes, let me explain our experimental result and the impact of deep learning and reinforcement learning. Our experiment is to make a design similar to a small maze. The result will randomly arrive at a position, and then let the machine continue to learn from the situation and use the mechanism of reward and punishment and the same evaluation to continue as retry and correct to the optimal model. The end will finally reach zero. From our experimental data, we can see the reward from 10 simulation to 400 simulation. We get better and better as the machine continues to learn and close to zero. Learning. Or machine learning algorithm that use neural network as parameter structure for optimization. Reinforcement learning. A machine learning algorithm that not only utilize existing data, but also obtain new data through exploration of the environment and use the new data to cyclically update and iterate existing model. The advantage of reinforcement learning is that it has great and does not require data annotation. Although adult learning is still inferior to adult learning, each learning must have a more stable application, so it gives people unlimited imagination. In future, every learning must can bring a more convenient life to human beings. Thanks for listening.